Hi, welcome to lecture number 10. Today we're going to look at motion psychology and criminology and other studies in the early 20th century. So I want to start by talking about motion and stop action. And the key figure in this area is Edward Muybridge. Perhaps you remember Edward Muybridge. He was the inventor of the neutral density device that allowed proper exposure of the sky in early landscape photography in the American West. And that included quite a number of views of Yosemite. He was also a photojournalist in San Francisco and quite well known in the Bay Area for his photography. So Muybridge was asked by the former governor of California, Leland Stanford, who owned racehorses, to study the locomotion of horses with photography. And as the story goes, this was a settling of a bet, and the question to be answered was, do all four of the horse's legs ever leave the ground at once? So Muybridge designed a system of photographing the movement of the horse with multiple cameras lined up along the track. And as the horses galloped, he tripped the shutter of each camera by crossing strings attached to the cameras, crossing strings across the track. So the third photograph in the top row, you see clearly demonstrates that the galloping horse does in fact lift all four legs from the ground at the same time. So this work was published in the science journal La Nature, the French science journal, in 1878. Incidentally, Muybridge had begun this process in 1874, but he was interrupted by a rather dramatic murder trial in which he was accused of murdering his wife's lover. He ended up being acquitted, and his earliest attempts at doing motion studies involved the very slow wet plate process. And he used a very bright backdrop for his images that was covered with rock salt that would help to create the high contrast image that you see. So the result is a less than sharp silhouette of a horse, but it does show the basic animal locomotion nevertheless. In France, we have a French physiologist named Etienne Jules Marais, and he had been working on motion studies as well. He saw Muybridge's publication in La Nature and continued his own experiments with photography and movement, however, somewhat differently. So here you see Marais' gun camera, a camera that is attached to essentially a gun that would be pointed at whatever subject was being photographed. So in 1880, he invented this device, and this allowed him to make rapid exposures from which he could record human bodily movement or motion of a bird in flight. And since the invention of the dry plate, faster exposures were a real possibility for photographers, and they're now able to stop action based on the speed of the emulsion and the improved camera function. And here you can see how this camera was used. Flight of the Birds according to the instantaneous photographs of Mr. Marais from 1882. And you can see that this man is pointing the camera, much like a gun, at the subject. And here you see different frames in sequence of the flight of the bird. And this plate that you're looking at is very reminiscent of the child's Viewmaster toy that you may be familiar with. Another invention of Marais was a rotating disc with slots cut into it that would be spun in front of a camera's open lens. And the resulting images recorded on one piece of film as the disc would be spun, allowing just a portion of the subject to register. And this was referred to by Marais as chronophotography, and this is one of the resulting images. They look very abstract. And here's an example of what that rotating disc camera looked like. And here's another example of a chronophotograph or chronophotographic picture that he made in 1882 of pelicans in flight. So clearly, Murray's work and Muybridge's work were major precursors to the invention of cinematic film or moving pictures. Murray continued his work on animal locomotion, and this led to a publication of The Flight of the Birds in 1890, which helped to influence early building of airplanes. So back to talking about Edward Muybridge's work. Muybridge was invited to come to the University of Pennsylvania in Philadelphia to do his research in 1883. They gave him a special studio space in which to conduct these studies. And during his time at UPenn, Muybridge made 100,000 images of movement of a wide variety of subject matter, including everyday tasks by humans, domestic scenes, and animal studies. So here we have the bald eagle flying. And here we see a male jumping over a boy's back, so presumably a leapfrog activity. Muybridge's photographs differ from Murray's in that they are not made with a single camera, but rather with multiple cameras at different angles from the subject. And Muybridge used up to 36 lenses with 12 to 24 cameras, placed at 30, 60, and 90-degree angles to his subjects. The two cameras placed at 30 and 60 degrees were able to hold up to 12 lenses each. And the 90-degree angle was known as the lateral or parallel view, and the others Muybridge referred to as the front and rear foreshortenings. With this whole setup, a successful session could result in as many as 36 negatives per action. And this is one of the devices that Muybridge designed to electronically control and synchronize the tripping of the camera shutters. So the cameras would be housed in a separate area and operated remotely utilizing this device. In Muybridge's studies, one sees a very wide variety of subject matter, simple everyday movements, dancing, athletics, walking up and down the stairs, people depicted in various stages of dress and undress, men wrestling, fencing. Here we see a very simple movement of a hand drawing a circle. So though Muybridge's work was widely admired by prominent scientists and inventors and artists, his work is not without some controversy. Marta Braun, a scholar in early photography, discovered that Muybridge frequently fabricated some of his final composite images by changing the arrangements from their actual sequential shooting order. So instead, he edited and moved around blocks of images to fit one's expected sense of sequential order, or at least his expected sense of sequential order. So apparently, somewhere in the neighborhood of 40% of Muybridge's movement studies are actually put together non-sequentially, which is somewhat counter to his claim that they are all successive images. So although Muybridge's intent was to stop action in order to study movements frozen in time, his work obviously was extremely influential in the development of motion pictures. So many refer to him as the father of the motion picture. When one puts a single frame back to back, several single frames back to back in sequential order and in rapid succession, the result is the picture in motion. So this is a zoopraxiscope that was designed by Muybridge as well. And this is a device that is made to play images in sequence. So in some ways, it's thought of as the first movie projector. So taking cues from Muybridge, Thomas Edison designs something called the kinetoscope, which is a very similar device. And adding his patented electric light bulb, as well as utilizing George Eastman's film and adding sprocket holes, Edison's able to devise a new way to run lengths of photographic film through a projector. one would use a magnifying glass to look through the device and see the images in motion. Auguste and Louis Lumière are credited with the world's first public motion picture screening on December 28, 1895. They called the device they used a cinematograph, which effectively functioned as a camera, a projector, and a printer all in one. One interesting aspect of these technological improvements is the concept that human vision is now expanded beyond what it was before. Photography essentially allows us to see that which is imperceptible in frozen moments of time. So, incidentally, after the Lumieres showed an image of a wall being built and broken in reverse, apparently the story goes that people were quite disturbed by this backwards moving image. It was somehow contrary to one's sense of reality. And this is Etienne Jules Mouret again. Mouret's last major works were devoted to the observation and instant photography of smoke currents that he produced in his what he called his smoke machine. And this is one of the first modern aerodynamic wind tunnels, in essence, showing the diverse shapes of wisps of smoke according to the obstacles that are encountered within their trajectory. This line drawing is based on Albert Lon's stop-action photographs and may have provided inspiration for Marcel Duchamp's very famous work, Nude Descending a Staircase, that we see in this image. So you'll notice those similarities between this and this. And another artist, an American realist painter named Thomas Eakins, used Muybridge's photographs in his teaching and in his artwork to demonstrate how animals and humans actually moved. He was particularly interested in human locomotion and engaged in his own photographic studies, such as the one that you see here of the pole vaulter. And this may be an example of how Eakins' painting is based specifically on Muybridge's photographic studies of the horse's gallop. So Eakins is really interested in rendering the world more accurately by taking science into account and using photographic studies to both observe motion and light. So now I'm going to talk about a somewhat related artistic movement known as Futurism. And some of the figures in Futurism utilized photography in some interesting ways. So Futurism was an artistic movement that arose from Italy and was followed by artists, poets, and musicians. And it was inspired by studies of photographic motion as well as from other theories that were proposed by the Italian poet Marinetti. And he espoused a love of speed, technology, and also pathos and violence. The manifesto, the Futurist Manifesto, also included a passionate loathing of ideas from the past, especially political and artistic traditions. The Futurists were interested in the prospect of a world that was filled with motion, activity, and change. Anton Bragalia was a photographer who felt that Futurism would revolutionize photography by truly elevating it to art. He felt that photography should render the world's invisible energy and seek to reveal the spiritual aspects of life. And here we see this kind of blurry, motion blur example, photographic example of the futurist painter Giacomo Balla. It's a photograph by Bragalia. And in this photograph, we're looking at this particular painting, the dynamism of a dog on a leash. So the futurists were painting that kind of motion that you might capture in photography. So they were very inspired by that. Here's another example by Giacomo Balla, sort of a combination of the motion study, evocative of Murray's movement studies, as well as by Muybridge's movement studies, and also utilizing kind of a pointillist style. And here's another one by artist Gino Severini, The Dynamism of a Dancer, 1912. And here it starts to move into almost kind of cubist interpretation of motion. Bragalia said, quote, "We are not interested in the precise reconstruction of movement, which has already been broken up and analyzed. We are involved only in the area of movement which produces sensation," end quote. So here's a photograph of a person typing and a photograph of a person playing the cello. So all of these were pieces of inspiration for the futurists. So another area that I want to look at is worker efficiency, kind of an interesting subcategory of motion studies. So this is these are part of the time and motion studies of Frank Gilbreth and his wife. And the Gilbreths of the cheaper by the dozen fame were interested in determining the most efficient means for modern factory workers to complete their tasks as to allow maximum productivity and minimal worker fatigue. So they were inspired by something known as Taylorism, which was a method of scientific management of worker productivity. And this was defined by American engineer Frederick Winslow Taylor. So Gilbreth made images that he called chronocyclographs, or time cycle images. And these are created by attaching small light bulbs to the worker's hands and making pictures as the light traced the actions of the worker. They then created these light tracings into three-dimensional wire sculptures, which were used to train workers for the types of movements that would create the most efficient production. Their work with photography was influenced very much so by the motion studies of Muybridge and Murray. And here we have the three-dimensional wire sculptures that were created. So now I'm going to move into a totally different topic. We are going to look at facial characteristics, hysteria, and criminology. I'm going to start by looking at some studies that were undertaken by Charles Darwin. So in 1872, Darwin asked friends of his to comment on the work of French physician Guillaume Benjamin Armand Duchenne. Duchenne believed that human faces expressed at least 60 discrete emotions, each of which depended on its own dedicated group of facial muscles. So to recreate these emotions, Duchenne applied electrical current to the faces of these test subjects and then created photographic plates of their reactions. So each photograph he proposed demonstrated distinct emotions. So Darwin disagreed with this concept. He showed a selection of these photographic plates to his friends over dinner and, without leading the conversation, asked them what emotions they saw. And Darwin's guests agreed almost unanimously about certain emotions. The emotions they agreed upon were happiness, sadness, fear, and surprise. But they strongly disagreed about some of the more ambiguous images that he showed. So Darwin distributed a questionnaire around the world, and although he couldn't send the pictures themselves, he asked people about facial expressions and gestures, such as blushing and shrugging, among different cultures. And his connections ensured that he received replies from travelers and missionaries as far as South Africa, India, China, North America, and Australia. Darwin aimed to prove that there's a series of so-called cardinal emotions that are expressed and perceived by all humans in the same way, and that these are innate or biological. So in Darwin's studies, we find an interest in describing and categorizing human emotion. And this notion goes back to the concept that one's physical attributes are an important indicator of human character. Darwin argues that the physical attributes of emotion are inherently the same in all humans, and that animals had emotions that they expressed in similar ways to people. And Darwin's overall hypothesis, as we know, is that humans are not a separate species and resulted from evolution and natural selection. So Darwin had a large collection of these photographs of human emotion, and particularly that of children from whom it was thought one might see the most accurate and raw emotion. And the photographs were contributed by a number of different photographers, not just Darwin himself. Okay, so now I want to move into psychology and so-called hysteria. So a key figure arises in this area, and his name is Jean-Martin Charcot. He's a prominent neurologist in France during the latter part of the 19th century, and he was responsible for establishing neurology as a firm field of medicine. So Charcot used hypnosis to induce a state of hysteria in patients, particularly women, and then studied the results. So he staged weekly demonstrations of this hypnosis, bringing on what he referred to as the hysterical attack. His aim was to make a methodical description of the attack, which he attributed to a state called hysteroepilepsy. His work was widely admired, and in particular by Sigmund Freud, who was a student of Charcot's at the time. Charcot was criticized for creating more of a theatrical event than an accurate scientific experiment. And here are some images, the stages of a hysterical attack as documented by Charcot. So he used the camera to document these episodes. This photograph is one of a collection that Charcot had made of these so-called hysterical patients, demonstrating the stages of an attack. His subjects are thought to have exaggerated expressions and gestures, and they're called upon by Charcot to dramatically act out their symptoms for the camera. Another thing I want to talk about is the field of phrenology and its relationship to some of the things that we're going to talk about in criminology. So phrenology is a concept that physical traits are directly related to human character. So this was developed by a German physician named Franz Joseph Gall around 1800. And the idea was that one could determine the characteristics of an individual by feeling the bumps and fissures on one's head. So this drawing shows how the head was mapped with attributes such as cautiousness, destructiveness, spirituality, sublimity, self-esteem, etc. These were thought of as brain organs, which were enlarged to demonstrate the individual's propensity toward that trait. So if you had a particular bump on your head that was larger in one area, that might give some kind of indication as to the personality or character or tendencies of that person. So an enlarged carnivorous organ, for example, might demonstrate a person's propensity to commit murder. So this led to other practices such as craniometry, which is the measurement of brain size and weight, and physiognomy, which is the study of facial features. These practices all found renewed interest as the field of criminology is developed during the late part of the 19th century. And here we see an illustration from Thomas Sewall's 1837 lectures on phrenology, showing the craniometer. So as we begin to look at the burgeoning field of criminology, we see the camera being used for studies such as this. So during the 1880s, photographic documentation of criminals becomes commonplace among the police. And in France in particular, Alphonse Bertillon, who is a French police official, develops a system of visual description of criminals. He's interested in identifying potential repeat offenders. So his system entails objective measurement and documentation of various specific facial features, such as the ears, eyes, nose, profile, etc. So he systematizes the method of documentation with consistent lighting, lens focal length, and camera to subject distance. So here you have a grid of all kinds of characteristics that have been recorded. Bertillon's system is based on 5 primary measurements: head length, head breadth, the length of the middle finger, the length of the left foot, and the length of the cubit, which is the distance between the forearm and the elbow to the extremity of the middle finger. He also added eye color and little finger length to his list. And here we see an image of a cubit being measured. So every measurement slowly reveals the workings of the criminal, according to Bertillon. Careful observation and patience will reveal the truth, he says. So an example of an individual identification card for criminals is shown here. This includes what we might think of as the modern day mugshot, and includes statistical information about one's physical appearance. The creation of a very large archive of information, such as those used in police work, strengthen the government control of the populace in some ways. So theories of physical evidence of degenerate human character were quite popular across Europe and the Americas, and Bertillon's work influences the field of criminology around the world and becomes the basis of contemporary criminal archives. And here's an example of the photo studio that Bertillon would be using, as shown during the Columbian Exposition in Chicago. So the practice of criminal mugshot identification was common even in small town America. And this is an example of a local photo studio in Marysville, California. And you can see the painted backdrop here. So the police might bring their young criminal down over to the local portrait studio and have the photograph taken in profile view and frontal view. In England, we have photography being used in a somewhat different way to identify criminals. So Sir Francis Galton develops a system of what he calls composite photography, and that's using overlays of various criminal likenesses to create a type of criminal. So each one of these images is made up of multiple images, and they are layered one on top of the other. So here we see a comparison of various criminal types with what is called the normal population of men and officers. Multiple negatives are overlaid to create a picture that would give you a general physical type. Galton is best known for founding the science of eugenics, which promotes selective breeding to develop superior human types. And in Galton's words, this would improve mankind, and mankind should be better fitted to fulfill our vast imperial opportunities. Another example of Francis Galton's composite work is shown right here. Galton's work sought to find a general hereditary type, while Bertillon's system in France was in place to find unique individual characteristics. So you have two really different approaches to this systematic way of identifying criminals. Galton's work also extended beyond criminals and was used to describe tuberculosis patients, Jews, and other ethnic groups. Galton felt that photography was an ideal tool to demonstrate the objective qualities of humankind.